Hi everyone, my name is Vipul Sangma. I hope all of you are doing well and fine during this lockdown period. Today, I will be your grad mentor for subject physics. Today, I will be discussing about electric charges and fields. This topic is taken from a branch of physics that is called electricity. Electricity is basically divided into two groups, that is static electricity and current electricity. These are the two branches. In static electricity, the first chapter, that is electric charges and fields, it comes under this. That is given as chapter 1 in your textbook. The next chapter you will be studying about electric potential and capacitance. And then in the third chapter you will be studying about current electricity. Static electricity is also known as electrostatics. In electrostatics, the charges does not move in conductors. It is at rest. That's why we call it a static. Static means at rest. And current indicates that motion. When the charges will be in motion, then that electricity we call it as current electricity. So it is like this, the flow chart. Now, this term electricity is coined by an English physicist. His name is William Gilbert in the year 1600 AD. This word electricity is derived from a Greek word called electron, E-L-E-K-T-R-O-N, electron, which means amber. Amber is a sticky fluid that is extracted from amber tree. In olden days, hunters use this fluid amber to catch birds. They keep on a tray, they spread out this fluid amber on a tray, they keep food grains on top of it, and after that they keep it in the jungle areas. Whenever bird comes and tries to eat those grains, they get sticked up and the hunter comes and catches them. Electricity also has got that same nature, the sticky nature. That's why this is derived from the word called electron. So let us come to our topic now. This is chapter 1, electric charges and fields. Today, in today's video, you will be learning about the properties of charges basically. After that, in the next coming videos, we will see about fields. Electric charge. When we say electric charge, what it is? Then it is a characteristic property, or you can call it as a fundamental property of matter that gets influenced when it is kept in a magnetic field or in an electric field. Electric charge is of two types: a proton, which carries positive charge, and an electron, which carries negative charge. The basic unit of charge, we write it as E, that is 1.6 into 10 to the power minus 19 coulomb. Here C indicates coulomb, and this is the SI unit of charge. Now, one electron or one proton always will have this value of charge with them. A body can be charged by friction, by induction, and by conduction. Whenever a body we want to charge, then we should know that we have to either release electrons or we'll have to accept electrons. When a body receives electrons, then that body is termed as negatively charged. And when a body releases electrons to other body, then we say that the object or the body has changed into positively charged. So for charging a body, the body should either release electron or it should accept electron. Then the body will get charged. So in this process, suppose let me talk about friction. Generally, you all know that whenever we rub a plastic scale on our dry hair, then electron gets released from the scale to the hair. Now the scale gets positively charged in that process, and the hair will get negatively charged in turn. Now when I bring that plastic scale near small bits of paper, then the plastic scale will be able to attract small bits of paper. Suppose this is our paper. Initially, the charges were distributed like this on the surface. And one thing you need to know that any object which is charged, or if charges are present in the object, the charge resides only on the surface, not inside the body. Suppose this is a this is a neutral paper I have. Then I have rubbed one plastic scale in my dry hair, and then if I bring it near, now plastic scale when it is rubbed in dry hair, as I said already, it develops positive charge. This positively charged scale, if I bring near the paper, all these negative charges will come towards the scale, and the positive charges will be pushed the other end. And as the two charges are unlike, one is positive, one is negative, and paper being lighter, it will get attracted towards the scale. Likewise, when a glass rod is rubbed with wool, then the glass rod develops positive charge just like the scale, and the wool in turn will get negatively charged. Another example is that an ebonite rod, when I say an ebonite rod, it is a hard rubber mixed with sulfur. We call it as, in chemistry term, we call it as vulcanization of rubber. This ebonite rod, if it is rubbed in fur or silk, then it gains electrons, and then an ebonite rod gets negatively charged. This type of electricity comes under frictional electricity, or we call this frictional electricity, or charging an object by friction. The next topic is about induction. In induction, a body can be charged when it is brought near a charged object without bringing in contact. Keeping it at a certain distance, we can charge a neutral body. The second one, let us see. Suppose this is an insulating stand. Insulator of electricity, let us say it as wood. This is your uncharged body. The charges will be well distributed like this: positive, negative, like this. Now, if I bring a positively charged glass rod, suppose this is a positively charged glass rod, near to it, then what will happen? I am not touching them together, I am just bringing nearby. Then all these negative charges, whatever is there in the uncharged body, will come towards the glass rod. It will look like this, and all the positive charges will be pushed behind. That is on the other end. Now this uncharged body, if I connect it to an earthing, say you have connected one wire, and then you can also hold it. Then also your body also will act as an earthing. Then what happens? In olden days, people were thinking that these positive charges used to flow towards the earth, but nowadays we know that the positive charges does not flow towards the earth. Instead, the negative charges comes from the earthing and neutralizes it. And after it gets neutralized, only the charge left in this body is negative now. Now what you have to do is remove the glass rod, remove the earth wire, then again these negative charges, what is appearing on it, on the body of the object, will get spread out, and the body, the uncharged body, will become negatively charged. Now let us see the third one, that is conduction. In conduction, the uncharged body gets charged when you bring a charged body and keep in contact with it. Suppose here, this is the uncharged body, as I said before, neutral body. The number of protons and number of electrons both will be equal. Now if I bring a charged body and keep in contact, suppose this is a cubonite rod, negatively charged cubonite rod. Then the moment you keep the cubonite rod, negatively charged rod, to this body, then this body will get influenced by the cubonite rod, and then negative charge, number of negative charge, if you look now, dominates the positive charges. So automatically the body will gain electrons from the cubonite rod, and the body will get negatively charged. The number of negative charges will become more. After you remove the cubonite rod, you will gain electrons, and then the body will get negatively charged. Little bit is different in induction. When you bring positively charged body, then the neutral body gets negative charge. It's reverse. Whereas in conduction, if I bring positively charged body to a neutral body, then the body will become positively charged. That you have to keep in mind. Now, charges are always conserved. That follows conservation of, we call it as conservation of charge. Charge can neither be created nor it can be destroyed. The total number of charge in an isolated system always will remain the same. You have seen in friction, conduction, induction, charges were not getting lost. It is there, but only transferring from one body to the other body. That is called conservation of charge. It follows superposition principle as well. If you have a number of charges, say Q1, Q2, Q3 and so on up to Qn, then you can add them algebraically. The net charge will be Q1 plus Q2 plus up to Qn. So this is also known as superposition principle of charge. This is also a very important property. Other than that, you have quantization of charge. Charges are always quantized. Quantized means in a body the net number of charge always will be an integral multiple of the basic unit of charge. Basic unit, as I said, for electron or proton, the value is 1.6 into 10 to the power minus 19 coulomb. So a body can have a charge, suppose Q is the charge, then plus or minus, plus for proton, minus for electrons, for negatively charged body, n times E, here where n is an integer. I hope all of you know about integers. It starts from minus infinity, it goes on, suppose say minus 3, minus 2, minus 1, then 0, then 1, 2, 3, 4, 5, 6, 7, 8, up to plus infinity. So these are called integers. Here you cannot see any decimal value, you cannot see any fraction. So like that, here also, the total number of charge a body possesses is always an integral multiple. Integral means n is an integer. Integral multiple of this basic unit of charge. A body can have charge say 6e. It can have a charge minus 7e. It can have even zero charge also. If you remove all the charges from a body. But it cannot have like 1 by 3e. No, it's not possible. Or 0.7e. It is not possible. Like this, it is not possible. So now let us do one small numerical from here, quantization of charge. Sometimes you may be getting question like this. Is a charge of 9.6 into 10 to the power minus 18 coulomb possible? If like this type of question comes, then what you have to do is use this formula from quantization of charge. Any here we are not interested in plus and minus, as we are going to find number. Q, the charge here is, or you can do like this first. N, as you are going to find, you can write Q by E. Then Q is 9.6 into 10 to the power minus 18 coulomb divided by E. The basic unit of charge is 1.6 into 10 to the power minus 19 coulomb. Coulomb will get cancelled. 6. Let us calculate it. After decimal 1 digit, so you can remove it. You can write 96 by 16 into 10 to the power minus 18. Minus 19, if you take it up, it will become plus 19. Coulomb will get cancelled. 4 4s are 16, 4 2s are 8, 4 4s are 16, 4 6 are 24. So it is coming out 6 into 19 minus 18 is 1. It will be 10. So it is coming out as 60. So it is an integer. So n value came out as an integer. So yes, this charge on an object is possible. So you write like this, since n is an integer, a charge of 9.6 into 10 to the power minus 18 coulomb is possible. Likewise, you may get any value here, and the process of doing is this one, and to find out. But you have to be very sure that here if you happen to get decimal, then no, it is not possible. I'll conclude here. Thank you for listening. Stay tuned and stay healthy.